Hello there, Mr. Sutton here, bringing you this IM3 1.3 Extra Practice Number 2 solutions on solving systems of equations using the elimination method. Now, for this particular one, we have a puzzle that we're going to be solving. So let me take a look at that puzzle for you. Right here, the riddle is, what do you call a donkey with a defect? And the idea here is we've got these 7 problems, these 7 systems of equations. We have to solve each one using whatever method. Elimination will probably be helpful on these, though. And whenever we solve one of these, we're going to look for the answer down below here and put that letter in whatever problem numbers blank that we just solved. So for example, for question 1, whatever letter I find, I'm going to put it above this 1 right here. So let's go ahead and start this thing. So for this problem, I could use substitution on this one and replace the y over here with 3x minus 1, and that's one way to get there. But I like to do all these with elimination just to show you kind of how that's done. So if I want to use elimination or addition, I have to first rearrange this second equation so that the 3x is on the left side. So that'll be my first step, is to subtract the 3x. Next, now that I've done that, looking at my 2 equations, if I add these together, nothing is going to cancel out. So one thing I could do to get my opposite-like terms would be to take this first equation, and I think it would be easiest just to multiply this by 3 so that I would have a 3x that would cancel out with my negative 3x. So multiplying this first equation by 3, that'll give me 3x, and 3 times 2y is going to be 6y, 3 times 5 gives me 15. Now I can go ahead and add these 2 equations together. That cancels out these 3x's, and y plus 6y gives me 7y. Negative 1 plus 15 is 14. Dividing by 7, we have y equals 2. Let me just plug that back in up here. Doesn't really matter where. So we have x plus 2 times 2 equals 5. So x plus 4 equals 5. And then if I subtract 4, I've got x equals 1. So my final answer then was 1 comma 2. Looking at my grid here for the answer, 1 comma 2 is right here. That's t. So I'm going to go to the blank for problem number 1 right here at the very end, put a t there, and that's not going to really help me solve this too much. I have to find several more letters before I'm going to have a shot at that. For this system of equations, if I look at my equations as they are, they're both in standard form, letters on the left, and it looks like I have opposite-like terms already, negative 3y versus positive 3y. So I'm just going to start by rewriting this one underneath the other one here. No changes at all, it's perfect the way it is. And then just add these 2 equations together right off the bat. So that'll cancel out my 3y's. 2x plus 3x gives me 5x. And then 3 plus 7 is 10. So dividing both sides by 5, I've got x equals 2. Now if I replace x with 2 over here in this other equation, I've got 3 times 2 minus 3y equals 7. 3 times 2 is 6. And then to get this y by itself, let me go ahead and subtract 6 from both sides. 7 minus 6 gives me 1. And then if I divide both sides by negative 3, I have y equals negative 1 over 3. So my final answer then will be 2 comma negative 1/3, which is going to match up with this L right here. So I'm going to put L next to problem 2's blank. On this system of equations, it's looking like if I add things together right off the bat, nothing good's going to happen, nothing's going to cancel. However, I think I could multiply this second equation by a number that would cancel out something with the first equation. So let me see if I want to cancel out my x's or y's. Let me just cancel out the x's. I mean, it's kind of half a dozen of one, 6 of the other on this. But if I multiply this second equation by negative 2, that's going to give me a negative 2x over here that will cancel out the 2x in that first equation. And then I'll have to do the same thing for everything else in this equation. So negative y times negative 2 is positive 2y, and then negative 7 times negative 2 is 14. Adding these 2 equations together now, I can cancel out those x's. So this is going to be 4y plus 2y is 6y. 10 plus 14 is 24. So then we have, dividing by 6, y equals 4. Now I have to go and plug that back in over in another equation. It could be this one here, but I like this one a little better because there's more room. So we have x minus 4 equals negative 7. And then if I add 4 to both sides, negative 7 plus 4 is going to be negative 3 for my x value. So then my answer, we've got negative 3, comma 4. Looking at my answer boxes down here, I see negative 3, 4 with h. So let me find blank number 3, that's right here, and put an h there. For this system of equations, it looks like everything is in standard form, letters on the left, so that's good. However, if I add these together, nothing's going to cancel out. So I'm going to have to first decide whether I want to cancel out the x's or the y's, and then multiply each equation by something based off of that. I'm just going to target the x's here, just why not? 3 and 2, those are smaller numbers to work with than 5 and 3, although not by much. So what do 3 and 2 both go into? Well, those both go into 6. So if I can make one of these a positive 6 and the other a negative 6x, I could cancel these out. That's going to be my game plan here. Let me start by multiplying this equation on the left side by 2. I'll make this the positive 6x. So we've got 6x, and then 5y times 2 is 10y. 2 times negative 10 gives me negative 20. Now I have to multiply my second equation by negative 3, again, so that I can get a negative 6x to go against the 6x. So we've got negative 6x, and then negative 3 times negative 3y is going to be positive 9y. Now 6 times negative 3 is negative 18. Adding these equations together right here, these second and third equations, the x's are canceling out. 10 and 9 gives me 19y. And then negative 20, negative 18, that's negative 38. And I just happen to know that if I divide by 19, negative 38 over 19 gives me negative 2 for the y value. All right, now I have to plug that back in. I'll just plug it in up here, because why not? So we've got 2x minus 3 times negative 2 equals 6. Negative 3 times negative 2 is actually positive 6. Subtracting 6 from both sides, we end up with 0 on the other side. And then finally dividing by 2, 0 divided by 2 is still 0. So that gives me the point 0, comma, negative 2, which matches up with A right here in my answer box. And let me find the blank for spot number 4. That's right over here, so we'll put an A right there. So it spells out Holt at the end. So I think I'm getting a sense of what this might be based off the joke. But let's just do the rest of this. For this problem, if I add equations together, nothing's canceling. But I can very quickly multiply this first equation by something that'll give me some opposite-like terms. So whenever I have something with an invisible 1 or negative 1 out in front, like this negative y here, that's usually a pretty good target for multiplying, because you can make it literally anything you want by just multiplying this one equation. So I want this to become a negative 9y to cancel out the positive 9y over here. So I can just multiply this first equation by 9. So that'll give me 7x times 9 is 63x. And then we'll have negative 9y. That was kind of the idea of all that. And then 6 times 9 gives me 54. Adding these two equations on the right side together now, the y's are going to cancel. 2x and 63x is 65x. And 11 and 54 adds up conveniently to 65. Dividing by 65, we see that x equals 1. Let's plug that back in over on the left side. So we have 7 times 1 equals, minus y equals 6. This is just 7 over here, so I can just immediately subtract 7 from both sides. That gives me negative 1 over on the right side. And dividing both sides by negative 1, we end up with y equals positive 1. Oh, that's kind of cute. So 1 comma 1 is our final answer. That matches up with S. So let me go and find the 5 blank. That's right here. Put an S there and move on. For number 6 here, there's a lot of ways you could do this problem. Kind of the first one that sort of leaps out at me, since we have x all by itself, is I could replace x with 4/3 y over in this equation, and then we would have all y's. The trouble with that is once you multiply that out, you're going to see that you're going to need a common denominator to combine these y's, and maybe that's a pain. So another way you could do this is to rearrange this first equation by subtracting 4/3 y. That would give you the letters on the left, standard form, 0 on the right, which is never a bad thing. And now we can figure out what we need to multiply one or both equations by so that these will cancel when we add them together. They will not cancel right away if we add these together. So let me pick the x's or the y's to get rid of. The y's just kind of look like a mess. I'm thinking I'll have better luck getting the x's to cancel out because I've got a 1x over here, I've got a 1/2 x over here. That's pretty easy to deal with. One thing I could do is multiply this first equation by negative 1/2, and then that would cancel with the positive 1/2 x. But that kind of seems weird to me, multiplying by a fraction. I could do it, I just don't feel like doing it. So instead, I'm going to multiply this second equation by negative 2. If I do that, negative 2 times 1/2 gives me negative 1. So we'll have a negative 1x to cancel out with the positive x over on that left side. And then if I do negative 2 times this next term, that's going to be negative 2/3 y. And then finally, 3 times negative 2 is negative 6. Adding stuff together on the left here, we have these x's canceling out. And now we have a common denominator with these thirds here. So negative 4 plus a negative 2 gives me a negative 6 over 3 with a y next to it. And we have 0 plus negative 6 is negative 6. There's a few things I could do at this point. One thing I noticed, though, is that 6 is divisible by 3. So let me just reduce this to negative 2y. And that'll make it a little bit simpler to deal with moving forward. Dividing by negative 2, I end up with, that'll be positive 3. So that's my y value. Now I'm going to plug that back in. Lots of places I could do it. I'm just going to do it up here, although you might be looking at this equation with x equals and be like, oh, that's a better spot. And you can do that. I just have more room over here. So this is what I'm going to go with. We've got 1/2 x plus 1/3 times 3 equals 3. Now this isn't so bad because 1/3 times 3, the 3's cancel. That's just a 1. So I have 1/2 x plus 1 equals 3. Subtracting 1 from both sides, we have 1/2 x equals 2. And then if I multiply both sides by 2 to cancel out that 1/2, I end up with x equals 4. So 4 comma 3, after all that fraction work, is our answer. And that's going to be P going in the 6th spot right here. All right, we got one more to go. For our last problem, this is truly a final boss battle for this puzzle. This is kind of just the sum of all your worst nightmares. We've got a fraction kind of thing going over on the right, and on the left we have a fraction with multiple things in the numerator. So this is just a mess. One way we could do this problem, we could start by splitting up this fraction to give us 5/3 x plus 1/3 y, and then we could kind of go from there. That might actually not be a horrible way to proceed. Because if we did it that way, then the y over 3 here would cancel out with the negative y over 3 over here, and that actually would work out pretty well. I chose to go a totally different route, though. I don't like messing with fractions to begin with, so I'm going to try to get out of this situation right away. One way you can do that is you can multiply the whole equation by whatever the least common multiple is of the denominators, the least common denominator, the LCD. 3 and 2, those both go into 6. So I'm going to multiply this equation here by 6. So if I do 6 times this first term, the 6 and the 3 are going to cancel out that 3, and that's going to, 6 divided by 3 is just 2. So I'm going to have a 2 times 5x, which is 10x, and a 2 times y, which is 2y. Over here on the right side, multiplying by 6, 6 divided by 2 is 3, 7 times 3 is 21. So that's one way to get rid of those fractions. I'm going to multiply this other one by 6 as well, because again, my denominators are 2 and 3. So 6 divided by 2 is 3. 3 times 5 is 15, so we have 15x. 6 divided by 3 is 2. 2 times negative y gives us negative 2y up there. And then finally, 6 times 4 is 24. So that was the hardest part of this whole thing. I mean, it's not smooth sailing from here, but at the very least, we've got rid of the fractions. One thing I do notice right away, conveniently, these y's are exactly the same except with opposite signs. So I'm actually good to just add these together and cancel out those y's. That worked out really nice. So I have a 10x plus a 15x, that's 25x. 21 plus 24 is 45. Well, this is not ideal. If I divide both sides by 25, 45 is not divisible by 25. However, we can reduce it. So if I reduce that by 5s, I've got 9 over 5. Not the best x value, but we'll work with it. And I mean, if you wanted to stop and look down at your table, you already see an answer that has a 9/5. But let's finish the problem just for the sake of the math here. That's what it's all about, right? So let me plug in this 9/5 to the x up here. So I have 5 halves times 9/5 minus y over 3 equals 4. And I could just cancel out these 5s and write this as 9 halves, or I could do 5 times 9, which is 45, and 2 times 5, which is 10, to get 45 over 10. That's what I ended up doing. I'm also going to turn this into a negative 1 over 3y, just rewriting it slightly so that y is not inside the fraction anymore. It's the same thing, though. And then this 4, since I'm immediately going to get rid of this 45 over 10, I'm going to rewrite this 4 with a common denominator that will let me do that. So instead of writing 4, I'm going to write 40 over 10. That's really 4, right? But now if I write it this way, I can subtract the 45 over 10 and have that same denominator. So 40 over 10 minus 45 over 10, that's going to be negative 5 over 10. And now to get y by itself, I can just multiply both sides by negative 3, the reciprocal of negative 1/3. That gives me a y on the left, and negative 3 times negative 5 is positive 15, and we still have a 10 in the denominator. Reducing 15 over 10, that'll give us 3 over 2. So we've got 9/5, comma 3 over 2 for this answer, and that does indeed match A, which we can put in that first spot right there. So just to finish up the puzzle, the question again was, what do you call a donkey with a defect? And the answer is asphalt, right? Because this first syllable here, which I'm not going to repeat, that's another name for a donkey. And fault, spelled this way, it's a play on F-A-U-L-T, which is like when there's something wrong with something. So there we go. And this whole thing, hey, that's what you put on the road. Very funny.